we take the lines away, the most interesting star, I think, the star that could be shocking in our sky is this one, Betelgeuse. It's a red giant star. If you put it where the sun is, it would extend out to the orbit of Jupiter. It's enormous. It's very unstable. It's about to explode.
NASA has sounded the alarm. Not about an asteroid, a rogue planet, or a solar flare, but about a star, a dying, trembling sun 600 light-years away that has started to act like it is taking its final breath. Its name is Betelgeuse, the red supergiant burning on Orion's shoulder. For months it has flickered and pulsed like a candle fighting the wind, its light dimming and swelling in unpredictable waves. If it explodes, the night sky will turn brighter than the moon and last for weeks. The question that keeps astronomers awake tonight is hauntingly simple. Has it already happened? The star that refused to stay steady. For centuries, Betelgeuse has been a familiar presence in our sky. Its soft crimson light crowns Orion, guiding travelers and storytellers alike. To ancient civilizations, it was a guardian. To modern astronomers, it became a measuring stick for stellar life cycles. Then, in late 2019, something changed. Telescopes from Hawaii to Chile began reporting that the star's brightness had dropped drastically, by nearly 70%. The Orion constellation itself seemed wounded, its shoulder dimmed to a faint ember. NASA redirected the Hubble Space Telescope to investigate. Observatories around the world scrambled to capture data. What they saw stunned even veteran astronomers. The surface temperature of Betelgeuse had plummeted by several hundred degrees Kelvin in just a few weeks, and the star's ultraviolet emission was erratic. It was as if the star's outer layers were convulsing. As scientists analyzed Hubble's ultraviolet spectra, the story became clearer. Betelgeuse had ejected a colossal portion of its outer atmosphere into space. A plume of gas and plasma had been expelled with such violence that it traveled billions of kilometers outward before cooling into dust. That dust condensed into an enormous cloud that temporarily obscured the star's light. It was not a simple flare or pulsation, it was a surface mass ejection, the stellar equivalent of peeling away a layer of its own skin. Andrea Dupree, astrophysicist at the Center for Astrophysics, Harvard and Smithsonian, described the event as something no model had ever predicted. Stars this size lose mass all the time, but not in chunks the size of planets. The eruption released energy equivalent to multiple times Earth's mass being hurled into space. When the dust cooled and drifted aside months later, Betelgeuse brightened again, but its rhythm was no longer the same. The Great Dimming, as it came to be known, was more than a celestial curiosity. It revealed that Betelgeuse's outer layers were unstable and that its convection currents were growing chaotic. Giant bubbles of plasma were rising and collapsing on scales of hundreds of millions of kilometers. NASA's Solar and Stellar Physics Laboratory compared the behavior to a heartbeat skipping erratically, clear evidence that the fusion engine within was struggling to maintain equilibrium. The light that reaches us today left Betelgeuse roughly 600 years ago. If the star had already gone supernova sometime in the 15th century, the flash from that explosion would still be on its way across the interstellar void. Each night we might be looking at the ghost of a star that no longer exists. That unsettling truth prompted NASA's emergency briefing in 2025. The agency assured the world that Earth was in no danger, yet acknowledged that Betelgeuse had entered a phase that no one fully understands. Its outer shell now behaves like a restless sea, rising and collapsing with unpredictable fury. Betelgeuse's story is no longer theoretical. It is unfolding in real time, one flicker at a time, while scientists attempt to look deeper into its core to uncover what drives these violent changes. The heart of a collapsing giant. Every star lives in balance between two opposing forces. Gravity tries to crush it inward, while nuclear fusion pushes outward, creating equilibrium. When that balance falters, a star's fate is sealed. Betelgeuse was born enormous, 15 to 20 times more massive than the Sun, and that size doomed it from the start. NASA's Goddard Space Flight Center often describes such red supergiants as cosmic sprinters. Their lifespans are measured not in billions, but in mere millions of years. Betelgeuse is around 10 million years old, an infant by cosmic standards, but already nearing the end. Deep in its core, hydrogen has long since been exhausted, forcing the star to fuse helium into carbon and oxygen. Layer upon layer of heavier elements build up, each burning faster than the last. Eventually, the core will begin fusing silicon into iron, and there the process halts. Iron is fusion's dead end. Instead of releasing energy, fusing iron absorbs it. When that happens, the outward pressure that holds gravity at bay disappears. In a fraction of a second, the core collapses. Temperatures soar to unimaginable levels, and the inner structure rebounds, hurling the outer layers into space in a cataclysmic detonation, a supernova. NASA scientists predict that when Betelgeuse collapses, it will release energy equivalent to the light of 10 billion suns. For several weeks, it will shine brighter than Venus, visible even in daylight. Whether it leaves behind a neutron star or a black hole depends on its exact mass, something astronomers are still debating. If it lies below roughly 16 solar masses, a neutron star the size of a city will remain, spinning hundreds of times per second. If heavier, the collapse will continue endlessly until nothing can escape. Determining the mass of a turbulent star 600 light-years away is no small task. NASA and the European Southern Observatory have spent years refining models using interferometry and spectroscopy. Yet in 2023, data from the Atacama Large Millimeter Array revealed an anomaly. Betelgeuse's surface rotation is far too rapid, nearly 5 kilometers per second, 20 times what theory predicts. Such speed implies that something once transferred enormous angular momentum to it. That clue opened a new line of inquiry. Could Betelgeuse's instability be the aftershock of a merger? Might its strange rhythm be the echo of another star swallowed long ago? The evidence was mounting, and as researchers dug deeper, a disturbing picture began to form. The cannibal in Orion. When astronomers combined data from Hubble, ALMA, and NASA's Infrared Telescope facility, they noticed chemical fingerprints that should not exist in a solitary red supergiant. The balance of nitrogen and carbon in Betelgeuse's atmosphere was skewed, suggesting that deep, processed material from the core had been mixed to the surface. That only happens under extreme rotational turbulence, exactly what would occur if Betelgeuse had once consumed another star. The idea was not fantasy. Stellar cannibalism is a well-documented phenomenon in binary systems. When one star expands into a red giant, it can engulf its smaller companion, pulling it inward until both cores fuse. The result is a single, unstable giant spinning far faster than nature intended. In Betelgeuse's case, such an event would explain nearly everything: its unusual rotation, its massive arcs of expelled gas, even the erratic pattern of its brightness changes. NASA's supercomputer simulations, conducted in 2024, modeled this violent dance. The virtual Betelgeuse consumed a smaller companion, about 1/10 its mass, roughly 100,000 years ago. The merger injected new fuel into the larger star's core, delaying its death but destabilizing its structure. The simulated aftermath matched the observations almost perfectly. Yet not all researchers agree that the smaller star was completely absorbed. Some believe it still exists, hidden within Betelgeuse's bloated outer layers, orbiting deep inside the Crimson Shroud. They call it the Beetle Buddy, a ghost star whose gravitational tug might be responsible for the supergiant's rhythmic pulsations. Every 14 months, Betelgeuse brightens and fades. Every 6 years, it follows a second, slower cycle. These regular beats resemble a heartbeat, precise and unyielding. Computer models from the Max Planck Institute suggest that a tiny companion orbiting within the star could create such tidal distortions. If true, Betelgeuse is not dying alone. When it finally explodes, the blast could strip away its outer layers and expose that hidden partner to the cosmos for the first time. To search for proof, NASA enlisted the James Webb Space Telescope. Its infrared eyes pierced the dense dust surrounding Betelgeuse, revealing structures invisible to optical telescopes. Early data showed turbulent filaments and arcs radiating from the star, likely sculpted by magnetic fields or unseen gravitational forces. Some of those patterns resemble bow shocks, signatures that could indicate an orbiting companion ploughing through the expanding gas. Whether Betelgeuse swallowed its partner or still holds it captive, one fact remains undeniable. The star is no longer stable. Its surface boils with titanic convection cells larger than Earth's orbit. Its magnetic field flickers unpredictably. It pulses, sputters, and releases waves of ultraviolet radiation that fluctuate with no consistent rhythm. Astronomers now watch it nightly, each observation a question whispered into the void. When will it collapse? What warning signs will precede the end? The answers may come not from the star's surface, but from deep within its invisible heart. When that heart finally stops, the universe itself will notice, and the first clue of its death will not be seen by the eye. It will be felt by detectors buried deep beneath Earth's surface. When the sky becomes fire. If Betelgeuse were to explode tomorrow, it would not begin with light. It would begin with silence. Deep inside the star, the final collapse would happen faster than anyone could comprehend. Within 1 second, the core would contract from a sphere the size of Earth's orbit to a ball barely 20 kilometers wide. The sudden stop of that collapse would send shockwaves tearing through the star's outer layers, heating them to billions of degrees and releasing an ocean of neutrinos. These ghost-like particles would race ahead of everything else, moving through space and through matter as if neither existed. Within hours, they would reach Earth long before the first flash of visible light. Buried deep beneath Japanese mountains, the Super Kamiokande detector, an enormous tank filled with 50,000 tons of purified water, would sense the faint tremor of their arrival. At that moment, humanity would know that a nearby star had died. When the light finally arrived, the transformation would be instant. Betelgeuse would erupt in brilliance, its luminosity increasing 100 million times in a matter of seconds. To the naked eye, Orion's shoulder would blaze with a new light so bright that it would cast shadows at midnight. The entire constellation would appear reimagined, the hunter's arm shimmering with a furious ruby glow. For weeks, the supernova would remain visible even in broad daylight, its brilliance rivaling the full moon. Astronomers estimate the explosion's apparent magnitude would reach about -12. The light would be steady, golden white, and visible from every continent. Photographers would capture it rising over temples, cities, and deserts, uniting the planet under a single sky. The star that had guided civilizations for millennia would burn one last time, illuminating both night and day. And yet, for all its fury, Betelgeuse's final act would not harm us. NASA's radiation analysis shows that the destructive effects of a supernova extend only about 100 light-years from the source. Betelgeuse is 6 times farther away. Its blast would enrich our skies, not endanger our world. Over the following months, the light would fade. The glowing remnant would expand outward as a massive nebula, a cosmic cloud rich in heavy elements. Iron, silicon, calcium, and carbon, elements forged in the star's core, would scatter through space. Within that debris would lie the raw materials of future planets, the seeds of new worlds. Centuries from now, long after the bright light disappears, telescopes will still see the nebula glowing faintly in infrared and X-rays. It will become a permanent landmark in our sky, a luminous scar marking the site of creation. The last time humanity witnessed such a spectacle was in 1604, when Kepler's supernova lit up the heavens. Records from that era tell of people unable to sleep at night, transfixed by the unending light. If Betelgeuse explodes in our lifetime, it will be even brighter. And for the first time in history, every instrument on Earth and in orbit will record the event from beginning to end. But while Betelgeuse teeters on the edge, another star system already follows its own rhythmic pattern of explosion and rebirth. To understand the cycle of cosmic death, NASA has turned its gaze to a different constellation, one where a star dies and is reborn again and again, like the universe's own heartbeat. The star that refuses to die. Far across the sky, in the small northern constellation of Corona Borealis, lies one of the strangest and most beautiful systems ever discovered. It is called T Coronae Borealis, or the Blaze Star, and it behaves like no other. Every 80 years, it erupts. This is no ordinary explosion. The Blaze Star is a binary pair, a red giant and a white dwarf locked together in a deadly embrace. The red giant is swollen and unstable, its outer layers puffed up and easily stripped away. The white dwarf, though small, exerts enormous gravity. Slowly, relentlessly, it pulls hydrogen gas from its companion, stealing layer after layer until enough builds up on its surface to ignite. Then, without warning, fusion begins in an instant. The result is a thermonuclear flash that makes the star thousands of times brighter. NASA and the European Space Agency have been tracking T Coronae Borealis for years. The last time it exploded was in 1946, before the space age began. But recently, scientists noticed something familiar. In 2015, the system entered what researchers call a high state. Its brightness increased slightly, matching the pattern seen before previous eruptions. Then, in early 2023, it dimmed for a short period, the final calm before ignition. Every sign points to another eruption soon. When that happens, the Blaze Star will appear in our night sky as a new, bright point of light. For a few days, it will shine visibly to the naked eye before fading again into obscurity. Astronomers compare it to the universe blinking, a reminder that even death in space is rarely final. Unlike Betelgeuse, the Blaze Star's explosions do not destroy it. They are part of an endless cycle of death and renewal. The white dwarf survives each eruption, resuming its slow theft of material until enough builds up for the next explosion. This process has likely repeated for thousands of years. For NASA scientists, studying T Coronae Borealis is like watching Betelgeuse's future in slow motion. The mechanics of nova eruptions help them model the physics of larger, more violent supernovae. It offers a glimpse into how the universe reuses its own debris. Every outburst releases heavy elements into space, enriching the galaxy's molecular clouds. Those clouds eventually collapse into new stars, which form new planets, which may one day nurture life. The connection is humbling. The carbon in every tree, the iron in every skyscraper, the oxygen in every breath, all were born in stars that lived, died, and exploded long before Earth existed. Betelgeuse and T Coronae Borealis are not isolated curiosities. They are chapters in the same cosmic story. NASA's briefing on Betelgeuse was not just about a single star. It was a reminder that our universe is constantly remaking itself. Destruction and creation are not opposites here. They are partners, locked in eternal rhythm. And this rhythm extends beyond individual stars. It shapes entire regions of our galaxy. For decades, astronomers assumed that our solar system floated in empty space, but NASA's recent studies have revealed that we live inside the remnants of ancient supernovae, an invisible bubble sculpted by explosions just like Betelgeuse's impending death. The bubble we live in. The Milky Way may seem calm from Earth, but it is full of scars left by dying stars. Our solar system drifts through one of them. This region is called the local hot bubble, a vast cavity in the interstellar medium filled with thin superheated gas. It stretches nearly 1,000 light-years across and envelops everything we know. In 2020, the German X-ray telescope Rosetta, launched aboard the Spectre RG spacecraft, began mapping the high-energy sky. The data it sent back astonished scientists. It revealed that the local hot bubble is not an isolated void, but part of a chain of overlapping cavities created by a series of supernovae over the past 15 million years. Each explosion swept away clouds of gas, forming a hollow sphere of hot plasma. Over time, these spheres merged, creating a complex network of tunnels linking different regions of the galaxy. NASA's follow-up studies confirmed that our Sun was not born inside this bubble. It formed outside and drifted in about 5 million years ago. That means every sunrise we witness today occurs inside the relic of long-dead stars. The air we breathe, the oceans that surround us, and even the iron in our blood were once scattered through this hot void before being drawn into the cloud that became the solar system. The Rosetta maps also showed something else, a faint, elongated structure extending from our bubble toward the constellations Centaurus and Orion. It resembles a tunnel carved into the galactic medium, a corridor of hot gas that might connect us to distant star-forming regions. Some scientists suspect that these tunnels act as channels through which energy and material travel between stellar nurseries and supernova remnants. If this is true, Betelgeuse's eventual explosion could send waves of radiation and cosmic rays along one of these corridors, energizing regions of space hundreds of light-years away. It could even help trigger the birth of new stars. The death of one red supergiant might breathe life into countless others. NASA's Next Generation Lynx X-ray Observatory, currently in development, is designed to explore these vast networks of plasma tunnels. Using sensors 100 times more sensitive than previous instruments, it will map the flow of energy across the galaxy, showing how supernovae sculpt the cosmos. The early data already suggest that the universe is far more interconnected than we ever imagined. Instead of a scattered collection of isolated stars, the Milky Way may function as a vast living organism, its arteries glowing with heat and motion. Our place within this network is both fragile and extraordinary. We inhabit a planet born from supernova dust, traveling through the ashes of ancient suns, surrounded by stars on the verge of repeating the same story. Betelgeuse's flickering light is not just a prelude to destruction. It is part of the grand cycle that binds everything together. When it finally collapses, its light will travel through the same cosmic highways that once carried the debris of other stars into our solar system. NASA's astronomers often speak about this with quiet wonder. They remind us that every explosion we witness is an echo of creation. The universe expands, evolves, and remembers. In that sense, Betelgeuse's coming supernova will not just mark the death of a star, it will be a revelation of connection, a final heartbeat echoing through the corridors of the galaxy. The universe does not repeat itself, yet its patterns never end. Stars are born, they burn, and they die, leaving behind the raw materials of everything we are. Betelgeuse stands as the next great messenger of that eternal story. When its light finally reaches us, it will be a reminder of both mortality and immortality, of endings that create beginnings. NASA's emergency briefing is not a warning of doom, but a call to witness. It is a reminder that the night sky is alive. Every shimmer, every pulse, every dying ember in Orion's shoulder is part of a story still unfolding. When Betelgeuse finally erupts, it will not be a tragedy. It will be a celebration of the cosmic cycle that made our world possible. So keep your eyes on the heavens. One night soon, Orion may blaze with a second sun. The universe will show us how beautiful destruction can be. And when that moment comes, remember that we are made of the same fire, that every breath we take is the echo of a star that once died, and every heartbeat is part of the same rhythm that drives the galaxy itself.